Okay, so let's start. Today I'll try to introduce you to the Apache Airflow tools. My name is Tomasz Kanik, and I try to explain what is this Apache Airflow, how you can use it, and what is it for. Okay. Maybe at first I try to explain the problem that business has. It's problem that we have a lot of different data stores or data source that need to be transformed to data warehouse, where it's consolidate enterprise and divide to different data marts. Data marts is parts of data, some kind of data partitioning that is necessary for specific kind of business that use this data. For example, analysis reporting, mostly analysis reporting, or next processing in other data house with different application. ETL is shortcut of extraction transformation load. This is the process when we processing mostly big data. Sometimes it's not big data because you need to say what mean big data. It's 2 gigabytes or 2 terabytes. It's up to the company. We mostly process terabytes of data. This is a typical data lake that appears in different companies. There is some supply chain, customer service, ERP, sometimes call center, retail, human resource, e-commerce, etc., warehouse management. Each data source has different formats, different amount of data, different data logic that's appearing in the data source, and it's quite complicated to process this data, and sometimes this data need to be connected from example from ERP and e-commerce or human resource and some supply channel, etc. So it's not a trivial problem we're trying to solve. There is problem with remote control. There is a typical data lake that happens if you have if your company aging, you're trying to create some data warehouse that is input for ETL processing. It can be Hive, Hadoop, or other data store, data warehouse you create. And before that, you have another data warehouse where it's the raw data collected, so it can processing in the between different data warehouse. In this situation, it's quite simple situation when you have one data warehouse and you process it by, for example, ETL graph by Python, SQL, Airflow, or Python, or other tools. Then, as you see, there is a data marts I presented on before slide, and there is some interface that uses this data. Okay, so what is Apache Airflow? We can read in documentation. It's a platform to programmatically auto schedule and monitor workflows. Generally, yeah, it's true. But what does it mean? It means that we can monitor and control data pipelines. You can create some pipelines that get source from a CSV file, for example, 50 gigabytes in CSV file. It can be a dump from some ERP or CRM system. And in pipelines, it processed, calculated, and on the columns add to this data, so calculation, processing of them. And then all this data are loaded to BigQuery, then it's analyzed by some scripts by data science team. And at the end, some data are put to the production system from this analysis. And all that tasks are connected, and it's one ETL pipeline. What else? Apache Airflow allows you to work with data in Python. It's one difference that you can find between other tools. You can easily define your own operators, executors, and use any library you need to, like Python or something like that. What is important that pipelines are configured as a code. If you do it with old Airflow, sometimes it cannot be configured easily. It requires a lot of changes in the code if you create some cron task that happen, for example, each day. If you need to change something, you need to change the cron, change the scripts, connected scripts, etc. So it's quite dynamically generated tasks. Okay, how Airflow appear on the world, on the market. It's developed by Airbnb, by Maxim Bauchenin. It's open source in June 2015, as I remember. And it started in Apache Incubator in the May 2016. But since 2015, it's used by very large projects. So we can say that it's not only something in incubator state, but it's really used by the huge companies. And we see that these tools will be in stable development. And we can be sure that it will be used in the next few years. What else is out there if we can compare Airflow with other tools? We have, for example, Ozzy, Azkaban, Luigi, well-known and good competitor for Airflow, and Shadowscope. It's work with Scala. And it's quite dynamic system that's developed on the market. As you see, there is a few differences in the workflow specification. Airflow allows you to dynamic create of the task, same as Shadowscope, but if you compare it with the Luigi, Luigi is the configuration that allows you to do your job dynamically. You need to stop Luigi, change configuration, start again. It's consume time. Sometimes it's stop operation that happen on the Luigi server, and mostly you cannot use it in the real dynamic environment. Because, for example, you're the banks, all clients use your services 24 hours, 7 days, so you cannot allow any time that your service will be not available. Sometimes it's specific situation that you cannot allow it. Other things is workflow trigger. Airflow allows you to use data if you create specific sensor and the time trigger. Luigi have a date time same and Ozzy. In the schedule scope, you have some goals, some definition of condition that trigger your workflow. It's specific kind of triggering workflow. Sometimes it's not very useful. When you use a workflow scheduler like Airflow, when you have ETL pipelines, it's the most common situation. So you have some process that is well defined, and you process from the one state, data from the one state to another state. Like as I described about the CSV processing. Other situation is machine learning pipelines. It's very useful when you prepare data for your, for example, your network. This data need to be sanitized. You remove the duplication. You clean this data, process in the manner that is some computation in this. You don't use the machine learning inside the pipeline, but you process this data. When you need a predictive data pipelines, because sometimes a huge company created data pipelines that cannot be predicted how it's end. You have many inputs that can happen when you start some tools. It's not this situation. Airflow is quite predictive when creating the DAX. I will describe what it is. When you have a general job schedule, if you have something that can be run by Chrome, of course it can be run by Airflow. What is the difference between Apache Airflow and other tools that you can use? For example, Apache allows you configuration as a code. So you can easily configure the whole Apache Airflow and run it and change dynamically when you need it. Have a quite nice UI. So it's very useful if operator of the Airflow don't need or not are the developer DevOps. They can be, for example, data scientists who run some tasks and get on the output some result of processing. You have centralized configuration. It's very useful. You can make resource pooling using Airflow, and it's quite extensible. There is some screenshots from my Airflow. As you see, there is information about the running tasks, some schedules. It's used the cron format. Who is the owner of this task? Some information how it's processed in from the history view. Last run, number of currently running tasks, and some action menu. There is a manual run and other things. Oh. There is an example of some tasks that run. There is some task in this script, and as you see, it can move to another method. Because tasks run some methods or execute some code. There is a very useful view when you can see the tree view of your the acyclic graph, and when you run it and how it's processed. If something happens wrong, it's red. There is a gun that you can see which tasks are slow and you need to work with them and make some changes in your code, for example, or ask to change some services that you use. And there is a code, you can use the web UI to see the code, but you cannot change this code there. There is very useful landing times, and you can see how it's processing each day. Sometimes when you have a lot of data, there is some peak, and the next day, for example, it can be information from accountants. At the end of the month, they push some data from the ERP system. You see there is a load, and in the other day it's quite low. How Airflow works. There is a few architectural parts of the Airflow. You see there is some worker, scheduler, web server, some metadata database, and web server that you see web UI on the screen before. Metadata database is this one. This is database store to store information regarding the state of the task. Database updates are performed using an abstraction layer implemented in SQL Alchemy. So you see, you can use SQL Alchemy in your script, Python scripts, and is natively supported. Same as Jinga templates can be used to in these stacks. This abstraction layer cleanly separates the function of the remaining components of Airflow from the database. And what else we have is a scheduler and executor, because it can work on the same nodes. The scheduler is processes that use tag definition in conjunction with the state of task in the metadata database to decide which task need to be executed, as well as the execution priority. Scheduler generally run as a service. Generally because sometimes you can set that scheduler will not be used and you run your tasks manually. It's this situation when you would like to run manually using these buttons specific scripts. Executor is a message queuing process that is tightly bound to the scheduler and determines the workers' processes that actually execute each scheduler task. If we look at the executor, there is a different type of executors. Executors are you can think about this as some kind of library. For example, we have salary executors that run the DAX on the different salary queries, QE. Local executor run some scripts on these local nodes that is execute. Moreover, in the last few months, there is some architectural changes where we can use the executor that is called Kubernetes executor, and each execution creates new Kubernetes pods to process data. So you can easily create some process that execute, for example, Java environment and calculate something, or calculate in Scala, Fortran, whatever you need. It's quite useful if you work with data science team. They use their own language or own environment, and you can process this data in the tools they prefer. So it's very, very useful. You cannot make something like this in other tools I presented before, or I don't know how to do that. Workers is the place where the magic happens, so place where you process the data. There's a simple example of a single node Airflow architecture. As you see, there's some executor. You can make an executor of the same node, but it's still one node. It's a situation when you have a few DAGs to process some small amount of data, and you don't take care about scalability. There's a typical situation in the bigger company. You have a multi-node cluster Airflow architecture. Moreover, you can create a multi-cluster environment. And as you see, you create a node with workers. And if you would like to scale it horizontally, you create more nodes with the workers. Or if you need, you can create master and the slave node for availability of the web server and scheduler. For example, you can have a different master and slave node on the different cluster. If you need scale it vertically, you add new salary daemon on the same node. So you create the vertically scaling. Okay, and I'm still talking about DAG and don't explain what is it. DAG is directed acyclic graph object. I don't show you the mathematical definition, it's useless now, but you can read it, it's well defined by a mathematician. In this construction of the graph, there is a rule you cannot create the loop. It's kind of the tree structure. Of course, it's not typically tree. You can merge the node, you can divide the nodes, it's up to you. But what is important, you cannot back. You go only further.
Basically like git clones.
Yeah, exactly. Simple explanation. As you see, there is some task that you run first, some branching, some branch, some process there, and join at the end. Of course, you don't need to end with the join. You can end with different nodes, for example, 5 nodes. Each nodes end with, for example, writing some files on the different servers. That's just example. As you see, there is some DAGs, real DAGs that is used to solve some complex tasks. And as you see, it starts in the different nodes. It can work like that. It's up to you how you create it. When you process data, it's very, very useful to start in the different places. For example, there you get data from the one source, there is get data from other, and you join this node in the one, for example, there. When you join this data and process it together. So at the end, you send the email. Very, very common situation. Basic concept of the Airflow. We have a DAG, some graph of operator usage. When we say operator, we say about some parts of code that make something, some transformation step. If we say task, it means something that is run. It's usage of this operator. There is difference because when you explain with the team something about operators, you mean that you need to change some code. When you say about task, it means that something processes run and is processing, and you need to look at the data that they process. So this is good to divide these two terms. Operators can be divided on the sensor and executor. There's a few other operators I will show you. Sensor is something that you can use to check the state. For example, if you use local file sensor, you can stop processing and wait when the data will be pushed on some SFTP server, for example, and you wait with your processing until it's happened. When we talk about executor, it's a trigger operator. For example, the HTTP operator. It's very useful. You can trigger to run some web services, or at the end of processing, you inform that okay, I'm done. There is a hook. Hook is a interface to external system. You can create your own hook. For example, you can connect to Facebook and inform on the board that I'm done, or something happened wrong during the processing of data. We use a Slack hook that is connected to Slack and informs us if something going wrong during the process. Of course, on the production, the development, it will be useful ton of logs. There is some advanced concept that you not commonly see. It's XCOM operator that sends message between tasks. There's something that's not happening in the different tools. You are able to have different tasks, and you can communicate between them. So you can send some information that there is something that they calculate that is needed by other tasks, but you don't wait to the time you join this task. Just communicate between them and synchronize or orchestrate this process. There is some trigger rules. You can create a multiple dependencies, for example, all success or on success, one success, etc. It's situation when you split your DAGs, the different parallel process, and at the end of processing, you require that every parallel processing task inform you that it's the success of processing. If one stop, you cannot say I'm processing this data in the proper way. You can define variables using the Redis database. You can branching using the Python function. Moreover, you can create a sub-DAG. So you can create the DAG inside the task in the DAG. So you can run the huge process that process data in the whole data warehouse. And in the some task, you don't have the parts of code. There is no operator. There is another DAG which one processing independently data, and you wait for some output from this this process. There is an example of simple DAG. There is one operator, it's bash operator, another bash operator, and third one. And there is a definition that T1 is upstream to T2, and T1 is upstream to T3. So like this way. There is some changes in the new version of Airflow. You can just write something like write it down.
This is some slide that it looks like changing. You can write it in this way. Yeah. And write it in this way. It's quite useful and better readable by human.
It's changed in the new version of Airflow. Okay, so maybe create some code. Idea is create the forex the acyclic graph, and what we do is fetching data from exchange rates, storing them in PostgreSQL database, caching the latest rates in Redis, so we don't read again the data we have from the previous fetching. Okay, there is foreign exchange rate API you can use. Is open exchange rates. You can register them and use it for example, use simple curve query. There is a result, and we create some database. I write all the currency that you can get from this API. So we create some simple table with rates. And there we start with the forex DAG. As you see, there is some import of the Python operator, HTTP hook operator, and Postgres hook. Because we need to hook the HTTP, the data, and we need to hook the Postgres to insert that into that, and Python operator to process it. There is a definition of methods getRates. As you see, there is a run of the Postgres hook, a connection to the rates database, rates table, pardon. There is an API hook which was connected to Open Exchange using method get. There is the response, valid pairs, and at the end we insert it into the database. There is some information that say, okay, because I read information about that API, it's refreshed every 1 hour. So we can say this data are valid for the next 1 hour time we get this data. There is a loop where we get this data when we process this data. And there is a Postgres hook that run insert to the database with the proper rates. There is a cache of the latest rates in Redis. So you see there is a connector to the Redis. There is some arguments for the DAG. As you see at the beginning of the DAG script, we have definition of the methods, and at the end we have the description of this DAG and arguments that are used by configuration execution. There is a definition of main DAG and sub schedule. There we get the rates. It's a task. You see, we use a Python operator, create some task. There is a cache latest rates task. And as you see, there is a definition which one are the first and which one are the latest one. We can write it in this manual tool. And when we try to use this process, we can echo the Redis cache. We see there is some information about rates for GPT. When we query the Postgre, we get the latest rates, as you see. So, as I explained, there's a quite useful tool that can be used maybe in smaller project, but in the situation when you process data and process it in the well-defined way, you can use it to dynamically change this process anytime you need. Everything that you put in the Chrome, you can put to the Airflow tool, and you can better manage this process. Okay, we're waiting for the one who will be the winner. So at 9 p.m., 10:30, as I remember, yes? 10:30, we try to find the winner. Thank you.